Mark Goodwin is the metadata coordinator at the University of British Columbia. He works closely with the Digital Research Alliance of Canada's Research Data Management team. He is responsible for the Federated Research Data Repository, or FRDR's, discovery service, and leads technical support for the DataCite Canada Consortium. He's passionate about improving access to information and is excited to help enhance discoverability of research data in Canada. Welcome, Mark. Thank you. Over to you.
Thanks very much for the introduction, Lydia. I'm going to take a moment to share my screen. Okay, can I get a thumbs up on that? Good. Okay, great. Yeah, thanks everyone for being here, giving me the opportunity to speak with you today. As Lydia mentioned, I'm metadata coordinator based out of the University of British Columbia, working in partnership with the Alliance. UBC is located on the unceded territory of the Musqueam, Squamish, Tsleil-Waututh, and Coast Salish peoples. And I'm very grateful for the opportunity to work on their land. The title of my talk is Redesigning the FRDR Discovery Interface, Better, Stronger, Geospatial-er. So yeah, pretty bad joke, I know. It was originally supposed to reference Daft Punk's song, but we realized it wasn't a direct quote. But thankfully, someone on our team saved the day. I won't mention who it is. They might have a few years on me, but they noted that it does quote the $6 Million Man. So I've never seen the $6 Million Man TV show, but at least the title works now. So I'm going to be talking about, first I'll start with a brief introduction to the Federated Research Data Repository, FRDR, and then I will speak specifically about FRDR's discovery service and give an overview of that, and then move into talking about the FRDR Discovery Redesign Project, which is what's coming next for the FRDR Discovery Service. So FRDR is a scalable platform, scalable federated platform for digital research data management and discovery. It is provided by the Alliance, and it includes three components. So there's the discovery service. It's a national discovery layer that indexes Canadian research data from repositories across Canada. So it kind of aggregates data for discovery. There is a data repository itself within FRDR that has dedicated curation support. And there's also preservation functionality with an Archivematica integration. So now focusing on the discovery service, this slide is meant to just kind of illustrate how it works. On the left-hand side, that little funnel diagram looking thing represents the metadata harvester. So this is how we pull in all the metadata for data sets that are in these repositories and make it available via a single point of search. So that's what that computer in the icon in the middle represents. And then on the right-hand side here, that screenshot is FRDR's current interface. So you can see the main search bar there. And you know, also the links to depositing data and some more information about discovering data there as well. And I will, in a few slides, I'll go into a little bit more detail about how the harvester works. So there are a few benefits for researchers, improved discovery of the research, of course, of the data, and really it's the metadata. So like I said, we're not actually pulling data set files. In most cases, we're not pulling data set files into the discovery service. We're just pulling in the metadata that describes those data sets. So users can search through the metadata and then access the data. There's a link to go to the original source repository, so users can access the data there. So this helps to break down repository silos because it's, you know, users don't have to go to different repositories to do the same kind of search. It's just one place. you can go to do kind of a one-stop shop search. At the same time, we are driving traffic back to the existing, the original source repositories. So like I said, there is, in every record, there's a link that takes you back to the original data set record page in the original repository. So we're still driving traffic back there. Users can go there to, download the data files and, see the full set of metadata, that kind of stuff. So it's really just bonus discovery that we're providing here. And lastly, creating interoperability between Canadian and international platforms. So FRDR harvests metadata from Canadian repositories, and in turn, FRDR is harvested by other tools. So those include OpenAir, which is an EU initiative, so it's in Europe, and it provides the same kind of discovery service, but on an international level. So FRDR metadata is available there. Data Citation Index is a part of Web of Science, and ProQuest Central Discovery Index is used by tools like Summon, which are commonly used by libraries. So the data is also available there. The discovery service at FRDR currently contains over 75,000 data set records from over 100 research data repositories. So some of the different kinds of repositories we harvest from: university repositories, for example, Scholars Portal, government repositories at all levels, so federal, provincial, municipal, domain specific, so research organizations, for example, and also any data that's deposited within the FRDR repository itself. Currently, there are two separate interfaces to search with. There's two separate search interfaces embedded within FRDR's discovery service. There's a text-based search and a map-based search. So looking at the text-based search here, and I'll explain why that is in a bit, but looking at the text-based search here, it's kind of your typical keyword search. This is the main FRDR search. Both English and French language are supported. You have some filters for refining results. And then if you click onto a record, it'll expand and show you some descriptive metadata, so you can get an idea of what that data set's all about. And then, like I said, there's a link back to the original source repository. Now, the map search is an adaptation of the open source Geodesy project, which is what I was working on before I joined the FRDR team. It uses the open source software GeoBlacklight. That's for the interface. Search results are driven by an interactive map. And even though it's a separate interface, it is still tied to the same source data indexing that FRDR's main search uses. The only difference is that it only contains data that is either geospatial in nature, so shapefiles, that kind of stuff, or if it's associated with a location in some way. For example, if it has coordinates or a structured place name in the metadata, then we're going to map that. We're going to use that to put it on the map. And this is something we feel sets it apart a little bit from more typical geospatial search tools, which tend to focus on geospatial data specifically. It could be a survey of residents of Ottawa. We would take that place name Ottawa and then map it, put a bounding box around Ottawa, and it would be visible on the map in that way. So it lends itself well to this kind of generalist discovery tool that FRDR is. And it's available in English and French. So I wanted to take just a moment here with this slide to speak to why geospatial searching is a useful thing. why are we doing this? Why are we going to so much trouble to bring this into the fold? Using a map to search is really helpful for if you're looking for anything that's associated with the location. So if location is a significant part of the research that you're looking for, or the research question you have, then using a text-based search can be really difficult. And the example I tend to give in this situation, and I use for this slide, is a researcher friend of mine who is studying climate change impact on tree lines in a region that's not really defined by official boundaries. It kind of touches into Alaska and the Yukon and BC and multiple parks. So if she wants to create a text search to capture this place, then it would look something like this. So I scripted it out of what it could look like here. So you'd start with BC, and there's a few terms that can be used for British Columbia or BC, but you don't want the lower mainland, so you want to make sure you're trying to only get northern BC in there. Now I mentioned it's also touching on Alaska and Yukon, so you need to capture that. There's also park names. The data could just be listed with a park name. There are multiple parks included, and you can see it just gets really complicated really quickly. Now, with the map search, you just zoom to that location, and then you can run your search there, much nicer. So this is a screenshot of the map search interface as it exists now. So how it works is the user here has zoomed into roughly North America on the map here, and what populates the results is all the data that's located within that window of the map. And you can move the map around, and it's going to automatically update your search as you're moving the map. So you can see here in this area, there's about just over 2,000 results. As you hover over each result, you'll see the associated location on the map. So you can see result number 5 is being hovered over, and then the bounding box, which is that blue box, shows you where that data is located on the map. And then you have some other more kind of typical search tools here. You can do a keyword search within the map search. There's some filters, you can sort in different ways, that kind of thing. Now, if you click through onto a record page, you'll get the same kind of stuff as the main further search, some descriptive metadata, a link back to the data source. And also, if it is geospatial data, if there's a geospatial file that's included with the data set, then you'll also get this nice geospatial preview. And also you'll be able to download that geospatial file right from this page. So this is kind of just like a nice bonus feature we offer for the geospatial data. Moving back to the metadata harvester now, I wanted to spend some time just kind of explaining how that works on the back end. So we have technically have a different harvester for each repository type. So not necessarily each repository, but each different repository platform. For example, Dataverse, CCAN, OpenDataSoft. There's a harvester written for each. And the steps, the kind of process that happens is the repository API is queried to get the list of records. And then for each record, there's a query to get the full metadata from the repository. And then that metadata is crosswalked, or in other words, mapped from the repository schema onto FRDR's metadata schema. And then the crosswalked metadata is written to FRDR's database. And I will speak a little bit more about that in the next slide. Then we periodically refresh the records. So we're capturing any changes to the records and also capturing any new deposits that are coming into those repositories. This is a look at FRDR's metadata profile, or you could call it a schema. It's compared to, other schemas that are out there, it's fairly basic. It's really just what we need for information we need for providing discovery. It's largely based on the Dublin Core standard, which is kind of a general metadata standard for typical fields like author, title, description, these kind of things. And then we also have some DataCite schema elements in there to have consistency with that standard, and some custom elements as well that are just helpful for us with discovery. So this might be something that people are familiar with, but I wanted to spend one slide just talking about metadata crosswalking and what that's all about. So crosswalking occurs when you have a set of elements or a schema that's associated with, say, a repository, and then you take all the metadata from that schema and you map it over onto a different schema. So, for example, FRDR schema. So in this process, you're kind of going through each field and then mapping it over either onto one-to-one onto a field in your schema, or sometimes you take multiple fields and combine them into one field. So there's different ways you can kind of deal with each one, and then that schema is used consistently. For like FRDR schemas used consistently in the FRDR discovery tool. The other point I make here is that we don't take necessarily all the metadata. In fact, we rarely do. We really just need what's relevant for discovery. So there can be a lot of subject-specific metadata in these repositories, or domain-specific. We don't necessarily need all that. We're just taking what we need for discovery, and then again, we're driving users back to those repositories to see the more fulsome metadata records at the original sources. So that was kind of an overview of how the FRDR discovery service operates and exists currently. So like I said, we have these two interfaces, and the reason that came about was we had the Geospatial-er project, which we were working on before, and we partnered with FRDR to build an instance of it, but we were still kind of testing it. We were still building it out, still developing it, and it's largely been successful. We've gotten good feedback, as has the main search in FRDR, but it was never intended to be a long-term solution to have these two separate interfaces. It's kind of can be kind of confusing for users to navigate the two different ones. It's not really ideal for a discovery service to have this. So that was when we decided we could rebuild it. We have the technology, we can make it better than it was, better, stronger, and yes, Geospatial-er. And that is my obligatory $6 million man joke. I promise I only have one more. So the Discovery Redesign Project is what came about from this epiphany. This started about a year ago. The goal with this is to combine the text search and the map search, to integrate those together into a seamless discovery experience, and then in doing so also kind of take a look at a full redesign and overhaul things to enhance search capabilities across the board. And early on in this project, we decided that the discovery platform was the discovery service was going to split off and become its own platform. So it's going to now be separate from FRDR, which is going to remain. It's going to be, the repository is going to remain as FRDR, and discovery is going to have its own platform. So I might be a bit young for $6 million man, but as a millennial, one thing I do know is memes. So I did make this nifty $6 million man meme, which I think is a sophisticated rendition of the project's process. Basically, what we're getting is the text search combine it with the map search, and then what do you get? Lunaris. So this is the name and the logo for our new platform. I hope you like it. We don't have much to show yet in the way of prototyping. It's still pretty rough. The prototypes are still pretty rough and under development, but we do have this nice fancy logo. So the name is meant to reference both humanities and the sciences and kind of invoke search for knowledge. So I have shared this at a few conferences, so unfortunately I can't say you're the first to see it, but I did mention that FRDR is going to be a repository devoted platform now. So FRDR is also getting a rebrand. So now I can say for the first time ever, FRDR's new logo. So as you can see, same kind of theme as Lunaris. We're splitting up, but it's an amicable split. We're still going to talk. We're still going to be friends. So we're keeping the same theme here. The image, kind of like Lunaris's logo image, is meant to invoke this kind of interconnected network. So now I will move into talking a bit about the redesign project and give you an idea for what our plans are and what we want to do here. So starting out with how we went into it, these are the goals we started with. Like I mentioned, we want to integrate the two platforms, the text search and the map search. We also want to expand the capabilities of FRDR search. So looking at things like advanced search and filtering, how can we, improve things across the board? And also leveraging persistent identifiers and controlled vocabularies, things like ORCID, ROAR, FAST, how can we incorporate that? And also here, kind of a general one, but very, very important, responding to diverse community needs of discovery for Canadian research data. So we really wanted it to be a community-driven project, and we've had different mechanisms for engaging the community. We created a survey. We've also done, early user testing along the way. And this last point I make here, I think, also illustrates this as well. It speaks to how different individuals are involved with the project. So we've got a core project team kind of based at FRDR. That includes the development team, who we work very closely with. And then we also have a working group. So the working group is made up of experts from different institutions across the country, and they've been absolutely vital to driving the project and bringing different voices and perspectives, telling us when we have terrible ideas or if we have good ideas. So that has been really great throughout. Running through here some of the activities we have done with this project so far to date. We started with an environmental scan and a comparative analysis. So looking at other platforms that were out there, what we liked about them, what we didn't. We established the working group also early on. And then we did some visioning, and we also made that user survey. So that was when we kind of decided there was going to be, it was going to become its own website. And, we brought that comparative analysis into the visioning. So that was really helpful early on. We then created a semi-functional, like very early rough mock-up that was just really meant to establish the overall layout that we wanted to see and kind of the flow of how it was gonna, how the site was gonna flow. And then we did some initial usability testing with that early mock-up. And we've worked with design firms to establish that logo that I just showed, and some of the branding and kind of the look and feel of how it's going to all shape up. Throughout the past year, we broke down these kind of design focused topics into what we call design modules. So this was really helpful to just kind of break up the work and let us really dig into these different topics. There's certainly overlap between them, but it was a great kind of mechanism letting us really kind of like get in the weeds, but in a good way, about how all this stuff was going to get redesigned. And now we've moved into development of an alpha prototype, so that is ongoing. This is a look at the different software components that are being reused by Lunaris. So there is the FRDR harvester, which I already spoke about. Globus Search is a text and geospatial search and filtering tool. Geodesy, that's that map search, so metadata and data retrieval processing with geospatial functionality. GDAL allows for geospatial file processing. GeoServer is a server for publishing and distributing geospatial data, and GeoBlacklight is the interface itself. It's the discovery layer. Running through a few kind of new features and enhancements that we have planned here. And I will give the caveat that the images here are still quite rough, pulled from some of our mock-ups along the way. So not a finished product by any means, but we did kind of want to shed light on some things that we're excited about introducing. So this one is functionality to allow the users to search by place name in addition to browsing the map. So currently users come and they kind of drag the map around and you can zoom in. We also want to introduce this place name search. So if a user knows the name of a place, but they don't know where it is on the map, they can enter it into the place name and then it'll just automatically zoom there. Some of the feedback we got from users coming to the map search was that they didn't necessarily know what to expect coming to just an empty map. So something we want to introduce is this idea of clustering. So the user can see roughly where data is located on the map and the density of it. Also, something that we're kind of functionality that we're lacking with the current map search interface is the ability to preview multiple geospatial files. As it is set up right now, if there's multiple geospatial files associated with the same data set, we break that up into multiple records, which is pretty confusing really for users. So for the redesign, we are building this new geospatial preview tool where users can come and see all the different geospatial files that are part of a data set in one place, and also all the bounding boxes associated with it. And a few other things here, linking to related publications and other repositories is something we're exploring. This kind of different ways to incorporate linked data, different metadata exports. So providing some consistent, different exports there and different metadata standards. Improved advanced search field options, so looking at how we can make advanced search more useful, and more. So of course there have been challenges along the way, and it's always helpful to talk about those as well. User research has posed a challenge at times. I talked about how we created a survey and we posted the questionnaire on the FRDR website. One thing we had to really keep in mind through that process was that we're really just hitting our existing users. FRDR, it's certainly the map search and FRDR itself as well are kind of relatively new tools. So we needed to make sure we kind of also thought about what the needs of potential users could be and incorporate that into our visioning, and really thought about that throughout this process. Some of the early testing we did presented some challenges because we were using this kind of like semi-functional prototype that we made using Figma. So some of it, and I've got a picture of it here. That's an example of like one of the pages we were using. So some of it is interactive, like you can click on certain things, but not other things. So the participants were really good in explaining aloud what they were intending to do and where they were intending to click, and what they were expecting to see. For something as complex as a map search, you can imagine like there was a lot that we really needed them to talk through. And fortunately, our participants were all fantastic. But yeah, it was kind of an interesting experience. And also just kind of the general idea of incorporating geospatial search into a database where not all the records are geospatial. And really, this is something that's not happening a lot in the RDM space. For the most part, you see geospatial tools that are more focused on geospatial data. You don't often see them kind of incorporated in this way in a more generalist search. One other group that is doing this is Research Data Australia. They have the same kind of hybrid search, and we have collaborated with them. Their team's been fantastic in sharing. We've shared back and forth information with them. But yeah, in a lot of ways, we're kind of breaking new ground here. So next steps for us, we are going to be continuing the development of the alpha prototype. So working with the development team, there's back and forth that happens there. Once we have a fully functional prototype, we're planning to do more user testing on that. And of course, we'll be continuing to work with the working group and consult their promotion, which is what I'm doing here today. And launch of the beta version, that's our big milestone. So that's coming in early 2023. We'll certainly be doing a lot of communications around that. So do keep your eyes open, mark it on your calendar. Just acknowledging now all the wonderful and very, very smart people that are involved in this project. It's definitely been a collaborative effort, and every person listed here has played a really significant role. So a huge shout out to everyone on this list. And that's all I have. Happy to take questions now, open it up for discussion. You can also contact me by email. And I thank you for being here. Thank you for listening.